Okay, this is some tutorials that you should do. We'll start with this disk. Let's draw it. This is a disk. It's rotating at about here, point O. It already has a moment acting on it. What is the moment's value? 5 Newton meter. This is the moment. About point O lah. This is O. And it also has a couple of forces. One forces. 10 Newton here. So you have two things which is contributing to the rotation of this disk. Probably a pulley. It is asking us how many number of revolution it must make in order to get 20 radian per second. Okay. Is it so hard to do? Just use one formula. Summation of moment is equal to I alpha, obviously. So if it is a disk, we can use this formula lah to get moment inertia. Which is half mr squared. So half. Mass dia berapa? 30 kilo. Radius berapa? 0.2 squared. Half mr squared. Dapat jawapan 0.6 kilogram meter squared. So I ni dah settle. Alpha nak cari. So cari summation of moment. So since it's rotating this way, this is a positive. So you've got 5 plus 10 times 0.2 is equivalent to 0.6 alpha. So let's do this. Let's punch in your calculator. How much did you get? 5 plus 10 times 0.2. 2 is equal to 0.6 alpha. So you got 7 divided by 0.6. Dapatlah alpha. Berapa jawapan? 7 divided by 0.6. 11.67. 11.67 radian per second squared. This is the angular acceleration. How much revolution must it make to attain 20 radian per second? How much revolution? I think something like this. You can use the third formula. Omega squared is equal to omega naught squared plus 2 alpha theta minus theta naught. Use this formula. Why? There is no time. And you've got theta. So, in order to achieve 20, so this one becomes 20. 20 squared. Omega naught originally at rest. 2 times 11.67. How many revolution? So this one becomes 2 pi n lah. Because it wants revolution. If it wants theta, then can lah also. Because 360, 1 revolution is equal to 2 pi. So let's do this. 20 squared is 400. So you're going to get 400 divided by you're going to get n. Let's solve this. 2 pi times 11.67 times 2. 284.8. 284.8. Did you get the answer? 400 divided by answer 1.40. So small lah. Is this correct? Have I squared everything? Doesn't seem right. Maybe this one. Maybe this one is wrong. Let's stick to theta first, Later we convert. Tapi betul lah kan, 2 pi times n. Kalau 20 rev, 20 times 2 pi. Correct lah. I don't think I'm doing any mistakes. Let's try it again. 2 pi times n. Did I multiply wrongly? 2 times 11.67. Okay. Times 2 times pi. 146.6. 146.6. Is there any mistake? Determine the number of revolutions you must make to attain an angular velocity of 20 radian per second. 20 radian per second, originally at rest. Okay, 2. Alpha is 11.67. This formula comes from V squared is equal to V naught squared plus 2AS minus S naught. Betul lah. 400. Okay. Answer. 400 divided by answer. 2.73. Rotation. Correct lah. 2.73. Yeah, this is a problem. Calculator press error. Yeah, most of the time you gotta punch in twice in order to get the proper calculation. Yeah, that's good. What else is there? What are we looking at right now? Exercise 13. 100 kilogram cylinder rolls without slipping. So this is good. So without slipping. This is easy. Why? Cari alpha, and then you can deduce already from A tangential is equal to R alpha. Because this is no slipping. Whatever it rolls, it will translate to forward linear motion. So something like this is easy to calculate. Okay, so let's do this. 100 kilogram cylinder roll. 100 kilogram cylinder roll. Cylinder. Yeah, you gotta find the I. Cari dulu I. I sama dengan half mr squared. Half 100. Radius 0.3 squared. What is the value? 0.3 squared times 100 bahagi 2. You get yourself 4.5 kilogram meter squared. This is your moment inertia. This is the angular mass. What is the unit? Not kilogram, it's kilogram meter squared. This is how much moment it has to provide in order for it to begin rotating. Okay, what else have we got here? Yeah, we should be doing free body diagram. This is mg. This is normal. What else have we got here? This is normal. So it rolls without slipping. It's rotating this way. So it has something called traction. So this traction, we gotta give it a name. What kind of name should we give it? F traction. This some sort of traction. Why is this traction here available? Because it moves. If you don't have this traction force here, this thing will not be able to rotate and move. So it has traction. So how do we solve this? Summation of moment is equal to I alpha. Where should we take the moment? Probably here. Oh. What next? So you've got 200. Right. So summation of moment is equal to I alpha. How do we write this? It's kind of rotating this way. So let's take this direction as positive. So you got F is in this direction. It's rotating that way, so it's a negative. Let's say F times 0.3. And what else? Is there anything else at this axis? No, there's nothing else. So this one will be equivalent to I alpha. And this one is a negative. Why? Because it's rotating this way. So you've got negative 0.3 F is equivalent to 4.5 alpha. So this is your first equation. First equation. In order to solve this, you need one more equation. What kind of equation is that? Let's continue. In order to get it going, one more equation, which is summation of forces is equal to max. So to the right is positive. So you have 200 plus F. This one is equivalent to mass times acceleration. Mass times AX. So you got 200 plus F is equivalent to 100 AX. So, do you remember this one, which is without slipping? So without slipping, we can use A is equal to R alpha. So this one we can substitute here. Now you're going to get 100 times radius berapa? 0.3 times alpha. So you have 200 plus F and this guy. So this one will become 30 kah? Let's arrange properly. This one will become 30 alpha, this one becomes 200 plus f. So this is your second equation. I guess if you want to use calculator, you gotta arrange it slightly more proper. Okay, let's use calculator. This one you gotta arrange it properly a bit. You're gonna get 30 alpha minus f is equal to 200. This is for your first equation. This is your first equation. Oh no, this is your second equation, okay? Second equation. Now look at your first equation, this one. Arrange it properly a bit so that you can use your calculator. So alpha is in front, put alpha in front. 4.5 alpha plus 0.3 f is equivalent to 0. 0. So arrange it properly so that easy for you to press your calculator. This is equation number 1. So now grab your calculator. 30 alpha minus f is equal to 200. 4.5 plus 0.3. Okay, press your calculator. You're gonna get alpha s, how much? And f is equal to how much? So mode equation, one unknown, 30, negative 1, 200. 4.5, 0.3, 0. Solve it, you're gonna get 4.444. This one is for alpha. 4.44 radian per second squared. How about F? F is your tractive force, traction force. Negative 66.7 Newton. Check your answer. AG. Alpha is correct. 4.444. Okay, so yeah, you haven't solved this one yet, right? You need to know the acceleration. Acceleration is A is equal to R alpha. You want to know this object, the acceleration forward is how much? Acceleration. So you gotta plug in back here lah. Radius 0.3 times 4.44. Berapa jawapan? 0.3 times 4.44. 1.332. 1.33 meter per second squared. Same as the answer lah. So this is what you get. Again, you've got a couple more exercises here that you can do on your own. This one is great. This one is great. This one is great. Why? Why is this great? Because later on, when you're doing your final year project, you are going to be designing something called... What is this? These are called... Yeah, this is called robot arm. So when you design your robot arm, you are going to be using something called a motor over here. motor. You're going to be using things like stepper motor, servo motor, servo motor. So something like this, the calculation is similar to this question. So don't come to me later on when you design your final year project. Your motor cannot rotate your arm. Cannot rotate. Why? There's not enough torque. Torque not enough. Why not enough? You do not calculate. You don't calculate it properly. So this is why we learn this chapter. You'll be using a lot of information from here in your final year projects. So some calculation like this, yeah, you need to really understand. Right. So this one, this is your IG, remember? Now you got to use parallel axis theorem and transfer the whole thing. This is your D. You got to get IO, which is equivalent to IG plus MD squared. Then you can use this in the formula of moment is equal to I alpha. Summation of moment is equal to I alpha. Then you'll be able to get what is this alpha rotation. So learn. You have to learn. Yeah, something like this is also very similar. Robotic arms. What else? Some sort of some sort of lever that you want to automate. Maybe you've got what this is your car. Okay, bad drawing. This is your MPV. MPV has this thing called tailgate. What a bad drawing. This is this tailgate. Okay, this is his bumper. What is this? Bumper. This is the MPV. Like that. Why you have a wheel here? This is a wheel here. This is the front door. This is the sliding door. This thing, you wanna put some sort of motor lever to open it up. Open it like that. Let's say you design something like this. So you wanna put a motor. Something like this, you need calculations like this. So you gotta remember mg is here. Mg is going down here. So these are the places where you should go whenever you are in need of any calculation similar to this. This is the subject that you learn every single thing. Okay, so apparently we have come to the end of this, the end of an era, the end of engineering mechanics. So before we write the end, few things we need to remember. Remember. What? Don't read engineering mechanics. You need to do exercise. So once you've done your exercise, you need to get the highest level of mastery, which is the highest level of mastery is teaching others. If you can teach, you are the master of that particular subject. And if you want to be a better at knowledge, you have to be able to explain simply. Simply. Yeah, explain simply. Yeah. Few things. This is very important lah. Do not read. Do exercise. And then teach others. Teach your friends. And explain it simply. If you cannot explain anything simply, you have not reached the level of mastery in terms of your knowledge. And I guess that's it. So, see you next time. The end. Bye bye.